Okay, so the mean of n numbers a, b, c, d and so on would be a plus b plus c plus d and so on till n divided by n. This can be represented as mean equal to a plus b plus c plus d n divided by n. Let us represent this as x. Now we have a formula for standard deviation. Again, I am not very keen on explaining you using formulas, but let us use it as a cursory explanation. I will give you in greater detail an intuitive definition of standard deviation, which would make things easier. This is the formula for standard deviation. Now, I know it looks a little scary, but please do not be afraid. It's way easier than it looks. I don't have the latex font, so that's why I had to resort to our basic keyboard, and that makes it look a little tough. But basically, it is the square root of the sums of the squares of the difference of the numbers with the mean. So let me explain you by an example. Suppose we have four numbers 1, 2, 3 and 6. What would be the standard deviation for these numbers? The mean would be, let us calculate the mean first, which would be 1 plus 2 plus 3 plus 6 whole divided by 4. This would be equal to 3. Okay, so we have found that the mean of these numbers is 3. Let us calculate the standard deviation. It would be 1 minus 3 whole square plus 2 minus 3 whole square plus 3 minus 3 whole square plus 6 minus 3 whole square divided by 4, that is the number of numbers, and the square root of this. Okay, it can be represented as, there you go, square root 1 minus 3 whole square plus 2 minus 3 whole square plus 3 minus 3 whole square plus 6 minus 3 whole square divided by 4. Okay, now this is not very important. In fact, for this question, you would not even need to calculate any standard deviation anywhere. I'll explain you how. For that, I will have to tell you an important concept. For any n numbers, if a constant k is added to each of the numbers, the standard deviation of the new set of numbers remains unchanged as that of the original numbers. Let me tell you how to understand this intuitively. This is the statement. For any n numbers, if you add a constant k, the standard deviation of this new set would remain unchanged. How do we get this? One initial explanation would be that if we have initial values as a, b and c, in place of a you can plug in a plus k into the standard deviation formula. For b you can plug in b plus k, and for c you can plug in c plus k in the standard deviation formula. You will find that the result remains unchanged. Now, this is just a formulaic definition. Let me give you a more intuitive explanation of this. Let's say we have three numbers a, b and c, and obviously they would have a standard deviation. If all these numbers are added with a fixed quantity, say a plus k, b plus k and c plus k, it's intuitive that the mean would also correspondingly increase by k. That is, if the mean of a, b and c is m, the mean of a plus k, b plus k, c plus k would be m plus k. That means the mean has increased or decreased by a corresponding quantity k as each of the numbers. What is standard deviation? Standard deviation is a measure of the deviation from the mean of all these numbers. It basically tells us how wide apart are the numbers from the mean. So the difference between the mean and the numbers would remain same even if we increase the numbers by a quantity k, because the mean would also increase by k. So m minus a would be replaced by m plus k minus a plus k. That would remain m minus k. So the net deviation would be rendered the same. I think this would make things a little more clear. Okay. So let us return to the question. Is the standard deviation of the numbers a, b and c equal to the standard deviation of 4, 8 and 12? Okay. Now, this is the advantage of data sufficiency questions. You do not have to calculate the standard deviation of 4, 8 and 12. It is sufficient to show that the standard deviation of the numbers A, B and C is equal to 4, 8 and 12. You do not need to calculate anything else. Let me give you an example. Suppose we have a data sufficiency question. What is the value of 1 into 2 into 3 into 4 into x into y? Right? What is the value of this? Now obviously we cannot say this without the values of x and y. Suppose the first statement tells us that x equal to 5. The second statement tells us that y equal to 10. Now looking at the question which says what is the value of 1 into 2 into 3 into 4 into x into y, one would be tempted to actually start plugging in the values of x as 5 or 6 into the statement of 1 into 2 into 3 into 4 and actually calculating the values. Note that we do not need to calculate these values. All we need is, yes, x, the value of x is mentioned in the first statement. That tells us that it is sufficient and we can calculate the value of 1 into 2 into 3 into 4 into x into y using both the statements together. Hence, the answer would be C. One does not need to calculate the actual value of the expression. That's not what they're asking us. They are just asking us whether it can be calculated, the expression. Okay, so always keep that in mind for data sufficiency questions, that as compared to problem solving questions where you have to calculate the exact value, here you do not need to calculate any values unless required. Okay, is the standard deviation of the numbers a, b and c equal to the standard deviation of 4, 8 and 12? Let us consider the first statement. It says 2 times of c minus a is equal to 16, which tells us that c minus a would be equal to 8, which implies that c would be equal to a plus 8. Right, correct? C plus 8. Great. Now this statement tells us nothing about b. So this statement is naturally by itself insufficient to answer the question. Right? Now let's move on to statement 2. What does statement 2 tell us? Statement 2 tells us that 5b minus 4a is equal to 4 times of b plus 1. That's another equation that we have. Note that this is a relation between b and a as opposed to a and c in the first statement, right? Okay, yb minus a gives us 4b plus 4. This means 5b minus a would be equal to 4b plus 4, right? Which implies b is equal to a plus 4. Now again we have a relation between b and a. The first statement gave us a relation between c and a. It is quite obvious that we will need both the statements if we have to have any hope of calculating the standard deviation. So we can straight away eliminate options 1 and 2. There is no way the statements together individually can be used to calculate the answer. Okay, let's use both the data together. B is equal to a plus 4, c equal to a plus 8. Let us represent a, b and c such as a comma b is a plus 4. So a plus 4 and c is a plus 8. So in place of c we can write a plus 8. Okay, we have to check whether the standard deviation of these three numbers would be same as the standard deviation for 4, 8 and 12, correct? Now let us come back to the concept I taught you, that the standard deviation of three numbers, if subtracted or added with the corresponding quantity of k, would remain the same as that of the original numbers. Here note that in this expression a plus 4 and a plus 8, this set of numbers, a is a constant which is there in all three of these numbers. Let me represent it as 0 plus a comma 0 plus 4 plus a, sorry, 4 plus a comma 8 plus a. So a is a constant quantity. That means the standard deviation of 0 plus a, 4 plus a and 8 plus a would be same as the standard deviation of 0, 8, 4 and 8, right? Because we have just subtracted the quantity A. So now we know that this we have to compare with the standard deviation of 0, 4 and 8 is same as the standard deviation for 4, 8 and 12. Let us add the quantity 4 to each of these numbers, 0, 4 and 8. Okay, 0 plus 4 comma 4 plus 4 comma 8 plus 4. The standard deviation of 0, 4 and 8 would be same as the standard deviation for 0 plus 4 comma 4 plus 4 comma 8 plus 4, right? That means the standard deviation for 0 comma 4 comma 8 or a comma 8 plus 4 or a plus 8, which is a comma b comma c, is same as 4 comma 8 comma 12. This is precisely what the statement is asking us. So both the statements taken together is sufficient to answer the question, but each statement alone is insufficient to answer the question. So the correct statement is C. The correct answer is C. C is correct.